What's up, my people, and welcome to another video in Walrus Code. Today I'm going to explain to you this diagram which I built in order to create this file uploader. It is an application, a front-end application built in React, but it connects to a backend application built in AWS. And it is basically a file content uploader. I can choose whatever image I want and then upload it to the cloud, specifically to S3. Do you know S3? This is a very cool service. It is called the Simple Storage Service, 3S. That's why it's called S3. It is basically a storage which can be public or private, but you can use it to serve content, statically content to the world. And I'm using this in this application to serve images as a static content. So let's head us to the AWS Console, to S3, which is right here. I can see in buckets every bucket I have created in my account in the region. This is a global, but here you can see the region of the bucket, and this is the one I'm using today. So as you see, I have already uploaded this image, which is a dog image, JPG image. I mean, when I click over it, I can get the public URL where I can see the image, and this is exposed to the world. So this is a public URL. You can click on it from every browser, every location of the world, and it's gonna be how do you say it's gonna have a public access? Because in the permissions of this bucket, let's go to the permissions of the bucket. I have enabled public access, but there is a policy on it. I just allow to read from this bucket publicly. No one can upload so easily. I mean, in order to upload an image, and that is the other part of this diagram. As you can see, in order to be able to upload images to this bucket, we have to generate what is called a presigned URL. And this is a very important aspect of S3. With presigned URLs, you have ownership. You have like temporary credentials in order to access the bucket as with more privileges, like deleting. You have privileges like for deleting, uploading, or reading images. I don't know, but in this example we are going to generate a presigned URL in order to have the privileges to upload an image and so serve an image to the rest of the world. As you know, by default, the bucket policies just allow read-only policies. Anyone can read, but only the guys with privileges can upload to it. And in order to get the privileges, you have to call this REST API, which calls is integrated with a Lambda. But okay, let's explain this in a higher level, and then we are gonna see each component of this diagram. But first, if you like this kind of content, if you like the cloud, AWS, SDKs, and everything I explaining to you, don't forget to smash the like button and subscribe if you are new. I am uploading content like this every week, and I am also working on my English pronunciation. So if you have any feedback to my videos, please write your commentaries in the box below. So let's continue. Yes, this is a very easy way to create serverless application. You can create REST APIs using the App Gateway service from AWS, which is a serverless App Gateway, as the name says, and you can integrate this with custom backends. But the easiest way to create a REST API is integrating this gateway with a Lambda. And you know, Lambdas are just a piece of code that scales automatically, and it can also scale to 0. That is very, very important because you pay only for execution and not for time. I mean, on the contrary, you know, the EC2 instances, you pay for hour. How many hours do you have this EC2 instance running? Lambdas are different. You pay for execution. If no one calls your Lambda, then you don't have to pay anything. That is amazing. That is what I mean to scaling to 0. You can save a lot of money, but there is always a trade-off. But okay, setting up a REST API serverless with this configuration. This is a very classic duo. API Gateway with Lambda is very, very, very easy. And you can see here in the API Gateway console of AWS, I have this HTTP API where I only have one endpoint enabled. This is the endpoint that I called generate presigned URL. And this is here. We can go here to routes. And this is the route. Actually, it's called get presigned URL, just like I wrote generate. Well, I can correct this, but this is actually just a get. And there it is. Presigned. Okay, you know it's the same. Okay, and then you see I have an integration with the Lambda. I can configure this, but it is already done. This is the Lambda function. It is going to call every time I hit this get endpoint. And where's the URL of this API? This is generated automatically by this service, and you have to go to stages, default, and there you see I have an invoke URL which is going to call this REST API. But if I call this just like this, there is a message not found. That is because I didn't use the correct get method. So let's add to it the get method and let's see what happens. I don't expect this to work because look at this, bad input, object key or MIME type missing. So this endpoint is expecting two things: the MIME type of the content we want to upload to S3 and the name that is going to be written on the storage. So whenever we upload a thing here, we can head now to the bucket. Actually, let's go to the bucket and the objects. I have only one object which is called username dog, which is the name I gave to this image. That's why I am able to see this. This is the image that I already uploaded before I started the video, but yes, then this name was also the name of the, this name, username dog.jpg was sent to the Lambda in this request. So the Lambda generates a URL based on the name of the file that is going to be uploaded, based on the MIME type. In this case, the MIME type is image JPG, but it could be also image PNG, another format of image, or every content. You can also upload plain text, form data, anything. So here's the Lambda, guys, and you can already see it is integrated with API Gateway. And what else? It is a Java runtime. It is running Java code. So what do you think? Should we go to the Java code? Let's head to the Java code. That's why, as you already noticed, maybe I have IntelliJ running, and this is the code of the Lambda. Just this file. It's nothing more. It's just 70 lines of code. It's nothing more. It's very easy to understand. We are gonna review it right now. So first of all, I am using the AWS SDK software development kit for using AWS services with code. That is basically the only thing you need in order to program service and use AWS with code. And this is I'm using the version 2 of the SDK because there is a version 1 also. Let's see the dependencies I'm using for Java. I'm using, as you can see here, the SDK version 2.17. There's also the version 1, but I recommend start using the version 2, because I don't know when it's going to be deprecated, the version 1. And I also specified these dependencies S3 for the AWS SDK. So we need these dependencies for S3 too, because we are using this one, presigner for S3. We need this object in order to create a URL that allows us to upload with privileges to S3. So let's review very quick the code of the Lambda. First, the Lambda has only one public method, which is called onEvent. The signature of this method is very important. It accepts a map, which is basically a JSON, a generic JSON where the keys are strings and objects can be anything. It's like the any in TypeScript or JavaScript. And as a response, I give back another JSON. That's why I use maps. But you know, these are dictionaries or JSON objects. The concept is the same, you know. Okay, so then I check if in the parameters, you can see the query parameters. That's why I have this payload class. You have query parameters in your request where you specify the MIME type of the image, of the content, and the object key, which is going to be the name of the image uploaded in S3. And if any of these parameters is missing, you can return a status code 400 that means a bad input. As you already saw in the browser when we tried to hit the URL without query params. And you have also to respond, and whenever you have a correct request, you are gonna call this create presigned URL method, which is just a custom method I created. But I wanted to talk about this header here. Why did I add to the response this header? Because we have to enable CORS, you know, cross or in requests. You have to enable them. And obviously you will never use a localhost for a production application. You have to use only verified URLs owned by yourself. But as this is a test application, it is okay to use localhost as a valid origin. Or you could even use a wildcard here, but I think localhost is better. Anyways, that is not to be used in a production application. Just I wanted to remember you that too. Okay, so how do we create actually the URLs? Very simple. We use these four methods, these four stages. First, we use S3 presigner object, then we use the put object request, which is basically, we are basically saying, hey, this URL is for uploading objects, because you can also presign URLs for reading objects that are private. But in this case, we don't need a presigned URL for reading objects because our bucket is for public access read only. So we don't need presigned URLs to watch the images. And then you specify the MIME type, the name of the file, the bucket name is very important. I pass to the Lambda the bucket name through an environment variable, which we can already see here in configuration environments. Here is the bucket, the key is bucket, and the value, here is the bucket name, which we are getting here with the environment variables. And then it's basically done. You can specify the duration of your presigned URL. It can expire after 60 minutes, but you can make it much shorter, 1 minute, if you want a sure URL. I don't know, that is up to you. You can choose how much it should durate, so to say. And then when we build this URL, we can close the presigner object and we just return the URL in the body response, and status code is 200. Just like that, as easy as it goes. Okay, so, and we use JSON in this example just to transform maps, or JSONs I mean, in order to our custom classes. Yeah, you can avoid that, but I recommend using JSON and parsing to your known classes. That is like parsing the request properly, because so you can use your own types and check whenever there's a missing object and so on. And yes, I think that is basically that is the Lambda. What else? So whenever we hit a request to the Lambda receives the request of the REST API, and the documentation of this request is, where is it? Okay, you can look at this because there is a documentation that explains every aspect of this request object that we become from the API Gateway. But I don't have the link right now, but I can write that in the description of the video when it is uploaded. But yeah, basically then you receive the response, and the client, our application in React, then knows which URL to use in order to upload the photo, and then we make a put request, because we may upload stuff to S3 using put request. Put request. So we make two requests, one to the backend, or two requests are to the backend actually, but one to get the presigned URL and another to upload it. So there is a missing part that I am not explained today, but I'm gonna explain it now. What does it mean, this S3 put object policy? This is an IAM policy. I think I should write it down. IAM policies are very important in AWS. They make our applications secure. So in order for your Lambda to be able to generate this URL, we already saw the code here. It must have permission, write permission, put object specifically permission for this same bucket. Otherwise, whenever this Lambda if this Lambda doesn't have this permission, then it's gonna create the URL anyways, but the URL won't be valid. You are gonna receive a 403 or an access denied whenever you try to upload the image here. So the generator of the presigned URL must have access to the bucket. It's like the presigned URL inherits the privileges of the guy who created it. And that is the keyword, inherits permission. So when whoever is generating this URL must have the same privileges that it's granting to. So that's why you have to assign, and I'm gonna show you what I mean. If I go to the Lambda permissions, I can see the role of the Lambda. I'm gonna open it, and it's going to open a tab in the IAM console. And we can, here, check it out. We have two policies. One is the Lambda basic execution role. That is very basic. This is just in order to be able to send logs to CloudWatch and to create log groups. But this second policy is the one that allows me to put objects in S3, or you can see it also here. We have permissions in order to create objects in S3, but not in every bucket, just in the bucket we are using. This is the bucket we are currently using. So we have permission only over this particular bucket, and that makes our application much secure. So I think I talked enough about the backend. Now let's see what did I do in the React application. But first, let's look at this in action. Let's see the Lambda in action. So I'm gonna upload this beach PNG. I'm gonna click upload and watch the request. First, it's doing the get presigned URL request, and that is taking a while because it is the first time in a while that we call the Lambda, and then the uploading is very fast. Well, it depends on how heavy your files are, but this image was very light. It was lighter than 100 kilobytes. So, but do you see there are two requests, one to get the presigned URL, and we can also see the response, which is this URL. This is the presigned URL. It's a huge URL because it has an identification token, and you know, identification tokens are very long. In order to be sure, they have to be very long, and some headers also, and then we upload the image. So that's it. That is how it works. Now let's head to this application. This is a React application. It's very simple. I didn't want to exaggerate a little so much in this development. It may be not, it's not separating for I mean, I didn't build a component for each thing, which I would ideally do, but for the sake of the example, I didn't want to actually bring so much time in the front-end part, but I wanted to deepen in the backend logic because this is where the action is going on. But anyways, I'm gonna show you the basic components of this app. This is just one component that has we have here a button. It's just it triggers this on file upload, and we have this input file, which is the input selector where we can choose the file we want to upload. That is HTML native components. It's nothing wild to see here, but here in the file upload, whenever I push or I press the upload button, we can see that we have one action call with a get with this URL. Do you know which URL is this? This is the same URL of the API gateway because we are calling here. So I can see, I can watch here in the stages. This is the URL, it matches. So I'm calling here the API gateway with the proper path, and I'm passing two query params as we already saw, the object key, which is going to be the name of the file, and the MIME type. And you can, I think, you can see here there is already existing one file, but now as you can see we uploaded the beach file. Now we have a beach file here in the bucket, beach.png. It's amazing, isn't it? I can visualize it also. This is a public URL, anyone can see this. So whenever we receive the presigned URL, I save this in a variable and then I send it to an access put request, and this is the put request that is going to put our file in the storage. And it's very important to specify the header because otherwise it won't be recognized. As you know, your presigned URL is married, so to say, to a MIME type, and we send the MIME type in the request, in the first request, so it must match the MIME type, otherwise the request will be denied with a 403. And then whenever everything, and when the two requests, this is promise chaining. I don't know if you know it, but in JavaScript you can do promise chaining. I do a promise here, and then inside this then I return another promise, and then we can chain with another then, and so on. And then whenever we have our file uploaded, the file, I set the file name, and then it's going to be refreshed here in the React component of the image tag. That is basically, I would add something to this application. It is not finished. We should add an authentication layer. So that is my homework to do. I hope I can finish that soon, because I already worked with AWS Cognito, which is a very cool authentication service. So I would put here an authentication layer, so not everyone can get this pre-signed request, but only users that are logged into a certain application. Yes, that would make our app even safer. So as a recap, we have a backend with an API gateway with a Lambda, which are both serverless components. Actually, S3 storage is also a serverless. So our backend is completely serverless. We don't have to care about provisioning or so on. Maybe we can increase Lambda CPU memory, but actually it is enough. It has 255 megabytes of memory. That is enough for this example. Just creating a presigned URL, it doesn't take longer than 8 seconds when the Lambda is cold, and when the Lambda is warm, it takes like 15 milliseconds. Very, very, very fast. And this is a very easy way to set up REST APIs. Believe me, you can just code a little piece of Lambda code and deploy it, and that was. Oh, but I have not talked about deployment. How did I deploy this and the policy and everything? Well, the client is running locally, so there's nothing to deploy here, but I deployed the API gateway and Lambda code using the CDK. I think I never have talked about the CDK in this channel. In my Spanish channel, I have already done a couple of videos about the CDK, the Cloud Development Kit. You should read about it. It's a very cool way to write infrastructure as code, so we can describe this whole infrastructure as code. I'm gonna review it very, very quickly. So we have an application which instantiates this CDK config stack, but this is where the action is happening. So we describe, we have this setup bucket. So we create a bucket here in the CDK. We create the Lambda also. And look at this, the Lambda is running Java 11, I mean, with this architecture, and the code is compressed in this function jar. And look, in this same project, you can see I have two modules, one for the Lambda code and the other module is for the CDK. So in one Maven project, you can have the CDK, the infrastructure as code, and the application code. That is amazing because in one repository, you can build the two and easily deploy them. Very, very easy. So yes, this is the setup of the Lambda. I can set up the timeout, which is only 10 seconds. I can pass an environment variable. So this environment variable you see here, this was passed through the infrastructure as code. I specified here. And how do I get the backend name? Just get backend name method, and that is very, very nice because I can copy this environment, this whole application, this whole setup. I can redeploy it in another account or in another environment in the same account, and then I can have a production and a production setup and then a testing setup, for example. Very cool. What else? So, and the REST API is also set up here as infrastructure as code. I'm using this HTTP Lambda integration and the HTTP API. All those dependencies, I'm gonna show you now the dependencies of the CDK are here. I'm using the CDK version 2. This is the 220, this is the version 220, and these are two alpha integration, alpha modules, which are not stable yet, but you can anyways use them. I already used them for the HTTP REST API. This API, this setup is built on the top of code that is in alpha, but it's okay, it works. You just have to know if you use this for production purposes, the code may change because in alpha everything can change. But basically, yeah, I specified the endpoint here. That's why it's called so. I specified that in the infrastructure as code with a get endpoint. And that's it. And you can easily deploy CDK applications. Well, first you can check the CDK diff in order to check if there is any difference from what is already deployed and what you want to deploy next. And as you noticed, the CDK is also written in Java. This is Java code. You already noticed, I think. But you can also use TypeScript. And actually, there are many more examples in TypeScript as in Java. So maybe you can also choose TypeScript for the CDK. And lambdas, you can also write lambdas in TypeScript or in Java. That is up to you. There's no, okay, so there were no difference, and you can deploy just writing CDK deploy, and that is very, very easy, guys. So guys, that was the video of today. If you like this content, don't forget to smash the like button and subscribe if you're new. I upload content like this every week, or at least I try to do so. Nos vemos la próxima semana. We are seeing us the next week.